Hello everyone, welcome to the end of the section. Should be kind of short. We did most of the hard stuff in the last video. So, just as a little brief reminder, what we're doing is we're using the law of sines to solve these triangles. And specifically, we're talking about the side-side angle situation, which is a little bit trickier. With the situation we're dealing with, sometimes it'll be no solution, sometimes it'll be one solution, and sometimes there'll be two solutions, okay? So in the last example, we did 2a. There was two solutions, and now we're going to do 2b. So, we need to solve this triangle where, let's say, b is equal to 9, gamma equals 85 degrees, and c equals 12. So again, we're going to start by drawing a picture. And it doesn't matter what the picture looks like because you don't know what the triangle looks like. So just draw a triangle. Alpha, beta, gamma. B is the side opposite beta, so that's 9. Gamma is the angle 85 degrees. Oh, that actually is kind of close to 85 degrees. Got a little lucky. C is 12. Side opposite gamma. So again, this is a side angle triangle because we have a side, and then the next thing we have is another side, and the next thing we have is an angle. There's no angle between the two sides that we have. Okay, so we're going to use law of sines. So we always start by picking an angle and an opposite side that we know, and usually there's only going to be one choice for this. The only angle and opposite side pair that we have is 85 degrees and 12. All right. And then to choose the next angle and opposite side, well, the only other piece of information we know is the 9, and the angle opposite that side is beta. So do multiply both sides by 9. You're going to get sine of beta is 9/12, which could be reduced, times the sine of 85 degrees. And again, let's get a good idea of what this is. We need to solve this trigonometric equation. There's going to be infinitely many answers, and sometimes multiple of those answers are going to make sense in the context of a triangle, in which case you have two solutions to the triangle. Sometimes there'll only be one solution that makes sense, and sometimes there'll be no solutions that make sense. So let's type this into a calculator and see what we get. 9 divided by 12 times sine. Make sure that you're using degrees right here. The right-hand side is 0.7471. So there's going to be at least one solution, which is good. If the right-hand side, if this was like 5, there'd be no solution to that. So we're going to use inverse sine. Now let's not do it that way. We're going to use inverse sine, right? Beta is going to be inverse sine of all that to get an approximation for beta. So if we type that in to our calculator, we get 48.3438 as one possible solution. That's a really big degree sign. So we need to see, is there another solution that makes sense, right? That's the solution in the first quadrant. There's also a solution in the second quadrant, right? It's about 50 degrees, kind of looks like this, but there's also one in the second quadrant. This other one is 180 degrees minus 48. So beta prime, if there's a second angle that makes sense, it'll be beta prime, which is going to be approximately 180 degrees minus beta, which is 48.3438. And that's going to be 131.6562. And we have to say, okay, this is the beta prime, this is the angle in the second quadrant that solves this trigonometric equation. Does this angle make sense? And remember, an angle makes sense if it doesn't break anything. But you cannot have an 85 degree angle and an 131 degree angle in the same triangle. Those add up to like 216 degrees or something like that. The whole sum cannot be over 180, right? So note, right, gamma plus beta prime, right, is roughly 100, or 200 rather, and 16 degrees, which is way over 180 degrees. This is impossible. So we know there's only going to be one solution. All right. So we don't have to worry about two solutions in this problem, because we said, okay, there's two answers right here, but this answer doesn't make sense in the triangle. Adding up angles in a triangle cannot be over 180 degrees. All right. So let's finish the problem over here. We found beta, it's about 48.3. And again, remember, as soon as you find two angles, you can find the third one. So alpha is going to be 180 degrees minus beta, which is about 48.3 degrees, minus gamma, which is 85 degrees. And again, you just type that into your calculator. And you should get 180 minus 48.3438 minus 85. Oops. You need 46.6562 degrees. So about 46.7. Great. Now we have all three angles. We have two sides. We just have to find the last side and we'll be done. All right. And usually when you use the law of sines again, because we need the law of sines to find the last side, choose the same pair that you started with. So we're still going to have sine of 85 degrees divided by 12 equals, now we're not going to have beta and b anymore. We're going to have gamma and c. The sine of gamma, which is, wait, oops, not gamma and c. I meant alpha and a. This is gamma and c right here. All right. Alpha is 46.7 degrees. And a, we don't know. All we have left to do for this problem is to solve this equation, and we will be good to go. All right. So multiply both sides by a, multiply by the reciprocal of the left-hand side. You're going to get a is 12 divided by the sine of 85 degrees times the sine of 46.7 degrees. Okay. That'll be the last thing we're missing. So let's type that into our calculator. 12 divided by the sine of 85 degrees times the sine of 46.7 degrees. And again, it's a good idea to use more digits, 46.6562 degrees. You can get a little bit more accurate of an answer. You can get about 5.4306. This is our last side length. All right, and again, if you want to box each one of these answers as you're getting them, you can. But I think a lot of times it's easier just to have all your answers on the triangle. So that's about 5.4. So now we've filled in everything in the triangle, and you can see all the answers in one spot. But again, as a reminder, you should always do a little bit of a gut check when you are gut check when you're solving these. The biggest angle should be opposite the biggest side. Biggest angle is 85 degrees. Opposite side is 12. That's the biggest side. Good. The smallest angle should be opposite the smallest side. 46.7 degrees. Yep. That's good. This, I don't know. Gut check though. These angles are pretty similar. 48.3 and 46.7. I am a little nervous. Did I make a mistake? Doing my gut check, right? These should be similar angles and these should be similar sides, but 5.4 and 9 are pretty different. The angles do indeed add up to 180 degrees, so the angles look pretty good. Sine 85 over 12 equals sine of this divided by a. Multiplied both sides by a. Reciprocal. All right, I might investigate this a little bit more because my gut check feels a little weird on this one. But if there's a problem, I will let you know. All right. So let's do the last problem of this little group, and then we'll move on to the end of the section. All right. So just hold on one second. All right, let's do 2C. One side has length 4 opposite an angle of 50 degrees. A second side has length 10. Okay, so again, this is just another way that the question could be asked, and you have to draw your own triangle. And again, the drawing of the triangle is optional, but it's usually helpful. So just, I don't know, let's just make some random triangle, alpha, beta, gamma. One side has length 4, I don't know, pick a side. And it's opposite an angle of 50 degrees. So if that's 4, this has to be 50 degrees right here. A second side is length 10. Again, just pick any side you want. And once you fill in a triangle, you can set up a law of sine. So take a minute on your own and try to set up the first equation for the law of sines to solve this problem, okay? Okay, so what you should have gotten is that you start with the pair that you know, 50 degrees and 4. Get sine of 50 degrees divided by 4, and then use a pair where you only have one of the pieces. This can be sine of beta divided by 10. Solve for sine of beta. And you get sine of beta is equal to 10 times the sine of 50 degrees divided by 4. So let's see what this looks like. All right. Approximately what this is. You get 10 times the sine of 50 degrees divided by 4. That is about 1.9151. But immediately, you don't even need to use inverse sine right here. Sine always oscillates between 1 and negative 1. This is outside of the range of sine. So if you try to use inverse sine, you're going to get no answer. So specifically, this is no solution. And we're done. As soon as there is no answer for B, you can't solve the triangle. There is no solution to the triangle. And you can just be done right there, okay? So that's a quick example. These ones are the nice things to see because you get done with them pretty quick. So real briefly, two more problems on this section I want to talk about. So there are area problems. Like if you want to find an area of just any random triangle, you could use trig to find the height. Right, use trig to find h. Or you can also use the formulas that I'm going to give you. So if you look on Canvas, under the week 12 module where we're doing 10.1, there's going to be a bunch of formulas in chapter 10 that I will give you that you do not have to memorize. And one of them is an area formula. Okay, so law of sines is on here. It's upside down from what we're talking about with A's instead of alphas, but it's the same law. Area of a triangle says that it's just going to be 1/2 any two sides multiplied by each other, and then the sine of the angle between them. So you can use any one of these formulas for the area of a triangle. Okay? So let's just kind of do a problem and just show you how it's used. All right? So let's do example 3. Find the area where A equals 90, B equals 52, and gamma is 102 degrees. So really, you don't even have to draw a triangle here. Because what do we have? Well, I have two sides, and I have the angle between them. If you draw the triangle, you can probably see that a little bit more quickly. So you just go to your formula sheet. Your formula sheet says K is going to equal 1/2 A times B times the sine of that other angle. And again, this uses capital C. We can use gamma. It's equivalent. All right. So you just plug things in. You get 1/2 A, which is 90, times b, which is 52, times the sine of gamma, which is 102 degrees. Type that in your calculator and you're done. Okay, that's all there is to it. So right here, what we have is 1/2 times 90 times 52 times the sine of 102 degrees is 2,288.9. We weren't given units, so it's going to be some kind of units squared. If it were feet, it'd be feet squared. If it were meters, meters squared. Remember, area always has a squared unit. And that's how you just approach all these area problems. Sometimes you might not have the information to just jump in here immediately. So you may have to use the law of sines to find one of these. All right, but that's a pretty rare case. Otherwise, you just use whichever formula fits the data that you have. Okay? And that's pretty much it. There's some application problems, but all the application problems is just using the law of sines to fill in the triangles. So I don't think we need to specifically do one of these here. But if you have questions on any of them, feel free to reach out via email. All right?